Hello ma'am, myself Gautam. I am from CSCA section. My CA2 assignment is about Maclaurin's theorem with Lagrange's form of remainder. And let's start it. First, verify Lagrange's theorem. First function is f of x equals to 1 minus x whole to the power of 5 by 2. We should prove this function with the Lagrange's form of remainder up to two terms in the interval 0, 1. We'll see the what are the concepts involved in this PPT. First, exploring the Maclaurin's theorem and Maclaurin's what is Maclaurin's theorem, given function, Lagrange's form of remainder, calculations, and last we will end up this PPT with a good conclusion. First, exploring Maclaurin's theorem. In this presentation, we will explore the Maclaurin's theorem and Maclaurin's form of remainder and verify Maclaurin's theorem for the given function using the formula we have Maclaurin's journey. First, the beginning of Maclaurin's theorem, named after the Colin Maclaurin, who has invented the Maclaurin's theorem, and these are the terms in the Maclaurin's theorem. The given function, finding the derivative. First, in the given function, we should write the what Maclaurin's theorem in Lagrange's form of remainder general form, and then we should find the derivative of f of x, f double dash f, and also we should find f of 0, f double dash of 0, and we should substitute that values in the general form, that is f of x equals to f of 0 plus f dash of 0, f double dash of 0, x square by 2 factorial and so on, x to the power of n factorial into f n by n factorial, x to the power of n by n factorial. Lagrange's form of remainder, estimating the error. Lagrange's form of remainder is used to estimate the error in terminating a series after a finite number of terms and give an upper bound of the absolute error. And formulating Lagrange's theorem, Rnf equals to f power n minus 1 by c into n plus 1 plus uh, x minus whole to the power of n minus 1. Applying the formula, and we will get this. Okay, let's see. Verify Maclaurin's theorem for the function f of x equals to 1 minus x whole to the power of pi by 2 with Lagrange's form of remainder up to the terms in 0, 0, 1. Okay, let us consider f of x equals to 1 minus x whole to the power of 5 in closed interval 0, 1. Here the Maclaurin's theorem with Lagrange's form of remainder general form is f of a plus h equals to f of a plus h into f dash of a plus h square by 2 factorial f double dash of a plus and so on, h to the power of n by n factorial f to the power of n a plus theta x. Here interval is 0, 1 in closed interval, we all know that, and here a value is 0 and h value equals to x. We should take a value equals to 0 and h value equals to x. Then we get we substitute a in the general form. In a place we will substitute 0 and in h place we will substitute x. Then we get f of x equals to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus and so on plus x to the power of n by n factorial into f power n theta x. Here 0 plus theta h, I mean h place will take x and a place will take 0. That means 0 plus theta x, that means theta x. And since n equals to 2, they told us to find up to 2 terms, remainder up to 2 terms. So we'll take n equals to 2. And now now integrating this, differentiating this, f of x equals to f of 0 plus x into f dash of 0 plus s square, and this is general form. F of x equals to 1 minus x whole to the power of pi by 2, we all know that, and we'll substitute 0 in it, then we'll get 1. We'll take f dash of x, that is equals to 5 by 2. F dash of x, we will convert this 1 minus x whole to the power of pi by 2. That means we'll take 5 by 2 front side and we'll minus with 1. That implies 5 by 2 into 1 minus x whole to the power of 5 by 2 minus 1 into minus 1. That implies f of 0 equals to minus 5 by 2. This is the calculation of it. And f double dash of x, that means we'll have 5 by 2 previously minus 5 by 2, and that is equal into in upper in power we have 3 by 2, that will be coming front side, that is into 3 by 2 into 1 minus 3 by 2 minus 1, that means 1 by 2. Overall we'll get 5 into 3 15 and 2 into 2 4, 15 by 4 into 1 minus 6 whole to the power of 1 by 2, we'll get it. F double dash of theta x, we will take theta x here because we should want theta x in last. So 15 by 4 into 1 minus theta x whole to the power of 1 by 2. Now we will substitute all the values into the equation number 1. That implies f of x equals to 1 plus x into f dash of 0. We have 5 by 2 on x square by 2 factorial. That implies 15 by 4 1 minus theta x whole to the power of 5 by 2. 1 minus x whole to the power of 5 by 2 equals to f of x. We have 1 minus x whole to the power of 5 by 2. That is equals to 1 minus minus 5 into x minus 5 by 2 minus 5x by 2 plus 15x 15 by 8 into x square 1 minus theta x whole to the power of 5 by 2. We have when x equals to 1, when x equals to 1, we substitute 1 in place of x. That implies 0 equals to 1 minus 5 by 2 plus 15 by 2 1 minus theta x whole to the power 5 by 2. 0 equals to minus 3 by 2 plus 15 by 8 into 1 minus theta whole to the power of 1 by 2. We'll take this 3 by 2 and 15 by 8 to the uh, LHS side. That implies 3 by 2 into 8 by 5 will be 15 by 8 will be reciprocal when comes to the LHS. That implies 8 by 15, that equals 1 minus theta whole to the power of 5 by 2. We'll cancel this 3 ones and 3 fives are it will be cancelled, and 2 ones are 2 fours it will cancel. That implies we'll be getting 4 by 5. 4 by 5 equals to 1 minus theta whole to the power of 5 by 2. 16 by 25 equals to 1 minus theta. Now 1 minus theta equals to 16 by 25. We'll transfer this one to this side. Here it is plus, and when it comes to here it will be minus. Theta equals to 1 minus theta by 16 by 25. Theta equals to 9 by 25. When we will calculate this, theta equals to 0.36. That implies 0.36 will be lies between 0, 1, open interval 0, 1. Therefore, the Maclaurin theorem is verified by this uh, uh, problem. And at last I conclude that the every step in the Maclaurin theorem has clearly understand, and the presentation was a good, and I hope the understanding levels is very much higher in this presentation. And thank you for the opportunity and spending the valuable time for my presentation. Thank you for your valuable time for my presentation.